Okay, today we're going to look at solving quadratic equations. In particular, today we're going to solve for the x-intercepts, that's the quadratic equations, using the quadratic formula. So we're going to learn something new today. Okay, so it says the x-intercept of a function are important because when they are the solution to the equation y equals or f of x equals 0. In the past tasks, we have learned to find the x-intercepts of a function by factoring, which works great for some functions, but not for others. In this task, we're going to work on a process to find the x-intercepts of a quadratic function that has them. Okay, so we're going to go ahead and take a look at this first one. So I want you to graph f of x, or y equals x squared minus 2x minus 3 using a calculator, and then answer these questions. So I'm going to switch to my camera real quick and kind of walk you through the process of how you use your calculator to find that equation. So remember, we're going to hit y equals, and then here we're going to put in the equation. So here's your x squared minus 2x minus 3. So let's go ahead and look at graph. And from here, it usually defaults to this 10 by 10 window. So you may just be able to find the vertex by saying, hey, that's over 1, and then count down how many. You can hit this trace key to kind of get close to it. So it looks like it's pretty close to 1 and then negative 4. And if you even type in a 1 and hit enter, it will tell you it's negative 4. Your other option is to look at second graph. And then you've got a table of values. You may just have to scroll up or down depending on where it starts at to look at those and plot some points. Okay, let's go back and let's see then here. So we saw that the vertex was at 1, negative 4. Some other points on here, just by looking at this, you would know that the y-intercept's at negative 3, right? The constant term. And remember, your axis of symmetry always goes to the center of the vertex. So in this case, if we know the vertex, your axis of symmetry has to be x equals 1 from that vertex. The vertex of the function in this case is 1, negative 4. And you may have already plotted your x-intercepts, but if not, let's just factor it for a second and see where we get them from. So we're looking for what multiplies to negative 3 and adds to negative 2. So we have a negative 3 and a positive 1. Here we can use a shortcut, so we get x minus 3, x plus 1, and this is technically like f of x equals. And then remember, your x-intercepts are the opposite of those because our equation already has the minus. So it's 3, 0, negative 1, 0. So a positive 3 and a negative 1. If I wanted to just finish this, I'd maybe just reflect that y-intercept to the other side, because then we can say, hey, we've got a nice parabola here. Okay, so now we're going to ask some follow-up questions, and this is kind of new to us. So we first ask, how far are the x-intercepts from the line of symmetry? So here's our line of symmetry. I'm going right 2, or I can go left 2. So there's 2 away, like both left and right of the axis of symmetry. Okay, and then how far above the vertex of the x-intercept? So let's count how many. 1, 2, 3, 4. The x-intercepts are 4 above the axis of symmetry. Okay, we're going to talk about now how this relates to this equation we're about to learn about. So let's take a look. The relationship between the vertex and the axis of symmetry can actually be modeled by this equation. And this equation that we see here, x equals negative b minus 2a plus or minus the square root of b squared minus 4ac all over 2a, is the quadratic formula. So where negative b over 2a represents the axis of symmetry. And the square root of b squared minus 4ac represents the rise over the run of the x-intercepts from the vertex. So that's what we were doing in part D and E. So let's actually show you how these numbers are related to what we just found. So repeat steps D through E using the formula rather than the graph. Check your x-intercepts. So first, let's look at our equation. So standard form, remember it's always ax squared plus bx plus c. So I just want to know what a, b, and c is. So there's no number in front of x squared, so we just say that's 1. B is a -2, and the constant at the end is a -3. So if I wanted to check my axis of symmetry, I'm going to take negative b, which is a negative of a -2, all over 2 times 1. So you get a positive 2 over 2, and you get 1. And notice here, our axis of symmetry was that line, x equals 1. Okay, now let's look at that rise over run. So let's look at b, which is a -2, and we're going to square it, minus 4 times a is 1, times c is a -3. All over 2 times 1. So -2 squared is 4. -4 times 1 times -3 is really a positive 12. And then 2 times 1 is 2. So we're looking at the square root of 4 plus 12 is 16 over 2. So we get 4 divided by 2. And notice what we said above, right? So if we connect the vertex to that axis of symmetry, to your x-intercept, we're rising 1, 2, 3, 4, and we're running 2. You see that? So notice it matches what we found up here in D and E. They were going up 4 and over 2. So if we put it together and we want to check our two x-intercepts, notice we have this value right here is 1. Actually, I did a different color. Let's do it in, let's say, red. So we get 1. And then our equation says we're going to do plus and minus. And then this next part, we just said was 4 divided by 2. So we could say that 4 divided by 2 is equivalent to just 2. So we now have two different parts. We have 1, sorry, color coordinating here, plus or minus 2. So there's two different parts to this. 1 plus 2 equals 3. 1 minus 2 equals a -1. And see, that matches our two x-intercepts of positive 3 and a -1. The reason being because we're going up 4 right 2, but we also go up 4 left 2. So that's the plus or minus. All right, so we just saw how that connects the picture. So really what we're doing here is we're finding the axis of symmetry. The way it connects is through kind of the axis of symmetry and how far away it is from it. At the end of the day, though, I expect you to be able to recognize kind of when to use these, when to use it. Yes, we will get there, but also just be able to plug in the values. So we're going to need to know how to use the equation. I will always give it to you, and that's sufficient for now. Don't worry about if that picture didn't quite connect in your mind. I thought it would help some of you. Okay, so our quadratic formula, we know it's always in standard form, ax squared plus bx plus c, and there we have it. Notice this one is written all together, so it's all divided by 2a. It's the same as dividing each part individually. So this is equal to, if you want, the negative b divided by 2a plus or minus the square root of b squared minus 4ac, all divided by 2a. Those two things are equivalent, so if it makes sense for you to divide individually. Otherwise, you got to remember at the end to divide each part. Okay, so we're going to go ahead and do example 1. Sorry, the 0 returned to the other side of the line, but it is equal to 0. So we want to go ahead. I always start off, it's already in standard form. It's equal to 0. I want to know what A, I want to know what B, and I want to know what C is. So A is 3, B is 1, and C is a -1. So we're doing x equals negative b. So it's the opposite of b. So it's a -1 rather than a positive 1, plus or minus the square root. So of b squared, so 1 squared minus 4 times a, which is 3, times c, which is -1, all divided by 2 times a, which is 3. Okay, at this point, we're just going to go ahead and simplify. So we get -1 plus or minus the square root. 1 squared is 1. -4 minus times 3 times a -4 is really plus 12 all over 6. So then we end up with a -1 plus or minus the square root of 13 all divided by 6. And this is your final answer. So you'll notice with something like this, you're like, okay, that's not going to be just a nice number, right? So like if you like evaluate it on your calculator, we're going to get some like decimal approximation for where that crosses the x-axis. So let's go ahead and we're going to do it again. We're going to do it with a few different equations. So solve the following equations using the quadratic formula. I always start off, tell me what A, B, and C are. So A is 5, B is 3, C is -2. So we got x equals negative b, so a -3 plus or minus the square root of b squared. So 3 squared minus 4 times a, which is 5, times c, which is -2, all divided by 2 times a, which is 5. So we get -3 plus or minus the square root of 9. -4 times 5 times -2 is a positive 40. All divided by 2 times 5, which is 10. So we get -3 plus or minus the square root of 49 divided by 10. This one's a little bit different because this I can actually simplify, right? The square root of 49 is 7 divided by 10. Okay, so there's two different parts, and I would probably break it up at this point to say, okay, I want to do -3 plus 7 and divide it by 10. And I also want to do -3 minus 7 and divide it by 10. So that plus minus is indicating the two different solutions. Make sure you follow the order of operations. So we're going to do what's just on the top. -3 plus 7 is 4 divided by 10. Gives me 2/5. And -7 minus 7 is -10 divided by 10. So that gives me -1. So your two solutions here are x equals 2/5 and x equals a -1. So this one you actually could have factored, right, because we got these integer and or fractional exponents. Okay, let's go to the next one. The next one, it's looking good, but the problem is it's not quite in standard form. So we first have to add 4 to set it equal to 0. So x squared plus 6x plus 4 equals 0. Okay, now do the same process. A equals 1. B equals 6, C equals 4. So, x equals -b, -6, plus or minus the square root of b squared, 6 squared, minus 4 times a is 1 times c is a positive 4, all divided by 2 times a is 1. So we get -6 plus or minus the square root of 36, minus 16 this time, all over 2. Okay, so we get -6 plus or minus the square root 36 minus 16 is 20, all over 2. Okay, I'm going to take a little tangent here. The square root of 20, well, it's not a nice number, right, necessarily. It is something that we do know how to break down. So what multiplies to 20? Maybe you say 4 times 5. And then 4 breaks down to 2 and 2. So we've got a pair of 2's, which means 2, square root of 5 is equivalent to that. So we'd have -6 plus or minus 2 square roots of 5, all divided by 2. This is one of those ones where it does simplify a little further, and that's why I suggest, because remember how I said, like, hey, up here, you can either write it separately or you can write it together. I would maybe break it apart and say this is the same as -6 divided by 2 plus or minus 2 square roots of 5 divided by 2. What I find is that if you don't write it like that is that sometimes you forget to divide the 2 square roots of 5 divided by 2, and you'll just do -6 divided by 2 is a -3, and then you'll still put plus or minus 2 square roots of 2. But this is really plus or minus the square root of 5 now, because these 2's would cancel out. So this is your final answer. You can separate it if you want into two different parts to be like -3 plus the square root of 5. And then the other answer is the -3 minus the square root of 5. Okay, we got a few more to do. So this one, once again, we want to set it equal to 0. I don't like necessarily dealing with negatives, so I'm actually going to add the x squared and subtract the 1. So then we get 0 on the right side. So let's write in order. We have an x squared, we have a positive 8x, and -1 equals 0. So a equals 1, b equals 8, and c equals -1. So we got x equals -8 plus or minus b squared minus 4ac. So 8 squared minus 4 times 1 times -1 all over 2 times a, so 2 times 1. So you get -8 plus or minus the square root of 64. And then -4 times 1 times a -1 is a positive 4 all over 2. So -8 plus or minus the square root of 68 all divided by 2. Okay, we got to figure out the square root of 68. 68 maybe divides into, let's check this out. I'm thinking 4 times something. Okay, 4 times 17. And then 4 breaks down to 2 and 2, so we've got 2 square roots of 17. So here we have -8 plus or minus 2 square roots of 17 divided by 2. Because 8 and 2 square roots of 17 both divide by 2, I'm going to break it apart into 2 separate parts. So like the -8 divided by 2 plus or minus 2 square roots of 17 divided by 2. So -8 divided by 2 is a -4 plus or minus, the 2's cancel out, right? I'm left with the square root of 17. So this has 2 separate answers. -4 plus or minus the square root of 17. -4 plus the square root of 17, right? And then the second one is -4 minus the square root of 17. Okay, next, last but not least, we want to set it equal to 0. So I'm going to subtract a 12x and a 1. So we get 4x squared minus 12x plus 9 equals 0. So a is 4, b is a -12, c is 9. So x equals, -b. So this time we're taking a negative of a -12, so it's really a positive 12, plus or minus the square root of -12 squared minus 4 times 9. Okay, all divided by 2 times 4. So here we'd have 12 plus or minus the square root of -12 squared is 144 minus 4 times 9 is also 144. And then 2 times 4 is 8. So we have 12 plus or minus 144 minus 144 is just 0 all over 8. So here you really have just 12 plus or minus the square root of 0 is just 0 all over 8. So really just get 12 over 8, which we could simplify if you wanted to as 3/2. So in this case, there's just one solution. And what that means is that on the graph is your x-intercept is just here. So your graph looks in this case something like this, right? So it just sits on the x-axis, whereas all the other ones, they actually cross the x-axis twice. There's 2 x-intercepts. So that's kind of how the graph relates. All right, you're all prepared for your homework. Be aware that some of them will come out to like numbers, like we had in example 5 and example 2. Other ones will be what we call irrational things, so they're going to have square roots. So it could be like example 3 or 4, or even example 1 where it still stays as a fraction, but make sure you take that effort to simplify.